welcome back to Virtual MOSI. My name is Mark. I'll be teaching you guys today. I want to thank you guys for tuning back into our wonderful program that we have here today. So, this week has been all about chemistry. Yesterday we learned a little bit about atoms as well as the states of matter, and my wonderful coworker who did that yesterday is currently behind the camera today. Also answering questions on a computer is my other coworker Janet. So if you have any questions, be sure to type them in the comment section below. Either myself or Janet will get to them throughout the live stream, and if we don't, we'll get to them after the live stream. Awesome. So today is going to be all about compounds and mixtures. Now, before we hop right into that, we're going to give ourselves a little bit of background information. So for those of you who didn't see the live stream yesterday, it is still on our page, so feel free to scroll down and look at that. But we talked about atoms. Now, atoms are essentially the building block of the universe. They make up everything, from the shirt that I'm wearing to this wonderful whiteboard behind me, to even all this water that was left on the table overnight. Now, different atoms make up different things. Now, if we have multiple atoms, and depending on how many electrons they have floating around, and positrons and neutrons and stuff like that, they will make up different types of elements. Now, if you have an element that looks a little something like this, this is going to be our O2 element. Now, because this O2 element is naturally found bonded together, this is what we call a molecular element. Now, so a molecule itself doesn't have to be just the same element. It could actually be multiple elements fused together. So this right here is a very common element that I'm sure you guys all know and love and probably drink, hopefully on the daily, to stay hydrated. But this is our wonderful element, H2O. Now, H2O is essentially going to be what we refer to as a molecular compound. And that's because it has two different elements. It has two hydrogens and then one oxygen. And so these guys are bonded together. And so this is what we also call a pure substance. And so if we have a wonderful glass, and I'm going to draw a nice big glass up here for you guys, of water, this is filled with a pure substance. Now, the compound itself of this molecule can't be divided by any physical means. You have to break it apart chemically. And we'll talk a little bit more about that when we talk about mixtures. Because this whole lesson is going to be both about compounds and mixtures, we've already talked about our compounds. We're going to be shifting into our mixtures now. Now, mixtures are pretty interesting because, like atoms and like molecules, they're made up of the same stuff. So if we were to have a mixture, right, we're going to stick with our wonderful H2O here today, and I'm going to redraw that again. And I don't know if you guys can see it, but I am trying to color coordinate this for you guys. And so right now we have our water molecule, and I'll draw one more just for good measure. And so right now, if we have our water molecules, it's going to look a little something like this. And so I don't know if you guys can see that in there, but the water itself is going to be the only thing that is in my cup. Now, this, like we already talked about, is going to be a pure substance. Now, if we were to add something to it, let's say tabletop salt, that's going to change our pure compound into something called a mixture. And so I'm denoting this with an orange and a brown. And this is our sodium chloride, which is table salt, if you guys missed me saying that earlier. And so in our wonderful glass here now, we have a mixture. Now, I'm going to demonstrate this for you guys. I'm going to open up my salt. I'm going to pour a whole bunch of salt in there. That's great. And I'll walk up to the camera so you guys can see this a little bit better. But I've poured my salt into here, and I'm giving it a little bit of mixture. And the cool thing about salt is that it actually dissolves in water. So if I hold this back up to you guys again, you can't see the individual grains of salt. because the salt itself has dissolved. And now all those sodium chloride molecules are about the same size as the water molecules. And so this mixture is homologous, which means that it is all approximately the same size. And so if we were to try to separate this isn't something that we can quite use tweezers to pull apart, but it is something that we can physically pull the different parts away from each other. We can do that by boiling the water or even leaving this cup out to evaporate. Now, if we were to add something a little bit larger, this homogeneous mixture is going to turn heterogeneous. And so I'm drawing them in here. And now I didn't quite make my picture to scale, but the heterogeneous mixture essentially has particles of different sizes. And so we here in Florida, we all like to go to the beach, and I've already made salt water, so the only thing that is missing is going to be sand. And so now I have put sand into my wonderful cup, and I'm just going to swirl my hands off. So if I were to mix up this sand nice and quickly, you can physically see the grains of sand swirling around, right? Let me do that again for you guys back at home. So you can see the grains of sand swirling around. That's because they're larger than both the water and the salt molecules, which means it's heterogeneous, right? Now, I mentioned earlier, compounds can be pulled apart chemically, but mixtures can be pulled apart physically. We already talked about how we were able to pull apart the salt from the water, but instead of using evaporation, we can use something called filtration. And so right here, I have some wonderful coffee filters, and if I do this correctly, I should be able to pour out the water and the salt. So all comes on out. And now if I want to get this salt off of the water, we would put this in the sun, let it evaporate, all that fun stuff. And so, hold on, we're reaching the maximum of our filter. Too much sand, I think. And so now, what's end up being left over is going to be the sand. And so that's physically separating the sand from the rest of the mixture. Pretty cool, huh? And this is something that you guys can try at home as well, because I can continue to squeeze some of the water out of here. And once I'm done, all that will be left is the sand, which is going to be great. And there it is again for you guys. Now to squeeze a little bit more of the water out. Filtration as well as evaporation are two physical ways that we can pull mixtures apart. So, I know you guys all really enjoy compounds and mixtures, and I know that you guys are having fun today, but we're getting to the main event, friends. And I'm sure if you saw the promotional photo that we posted for today, you know that it is slime time! Woohoo! So, we're going to come on up, and we are going to do a little bit of slime. Now, after this live stream is done, we're going to be posting a couple of slime recipes up on our Facebook page. It'll look a little something like this. Now, you won't be able to get the full picture unless you watch the whole live stream, so be sure to stick around. So, we're going to start with making our very first slime, which is just the generic MOSI slime. So there's a couple of things that you need. First and foremost, you need glue. We just have regular washable school glue, but depending on when you guys do this at home, whatever type of glue you have will actually change how the slime reacts, or it could make it look cooler or not. I personally like the way that clear glue looks, right? So we have our wonderful school glue. We are going to be using, again, a whole bunch of water. And then for this first one, we're going to be using borax, right? And now for my ease of access, I already have pulled out the borax to this little cup. So if I'm not pulling from this box, it's because I did this beforehand. So, what we need, glue, borax, water. We also need one of these wonderful little popsicle sticks. So,
can you use clear clear school glue?
Yes, you can use clear school glue. It actually looks pretty cool because you can see kind of the bubbles forming in it. And also what we're going to be adding is going to be food coloring. It looks a bit cooler with the clear school glue. Also with glitter. It's going to be fun. But I did not get the go-ahead for glitter because my boss would probably fire me. So. So, wonderful. So first things first, we're going to start with 1/4 cup of water. And I'm going to pour it, and I'm going to mix it in this cup for you guys, just so it's clear and you guys can see it. And I'm going to take about 1/4 cup of water. And now for convenience sake, this Dixie cup's about 1/4, because I'm going to be using this 1/4 a few times. I'm going to be pouring glue in here. Now if you want to remake this slime recipe, but you want to make more at a time, you can just double it. Alrighty, so I have mixed my glue with my first 1/4 cup of water. And I'm getting all that glue out of there. Nice, and I'm going to start swirling this around. Really just kind of mix it up, making the water gluey, the glue watery, right? And so the water itself, as we know, is going to be a pure substance, but the glue is actually going to be a homogeneous compound. And so, or homogeneous mixture rather. So when you mix these two together, it's not a compound anymore, it's going to be a mixture. Right? So we have our glue and we have our water. We're going to set that aside for a hot second. Next thing is we are going to take 1/2 teaspoon of borax. So we have 1/2 teaspoon of borax. And we're going to dissolve that into 1/2 cup of water. Now, I want you guys to pay attention to how much water I am using here, because we're using quite a bit for this, right? And so now I have my borax and I have my water. And I'm going to mix these guys up. And so what's going to happen is I'm going to take my borax solution and I'm going to add it to my glue. And I'm going to do a little bit at a time while I stir up. And if you can get a nice close shot in there, Miss Catherine, we're going to see that my wonderful glue is going to start turning from a liquid into something that's a little bit more, well, slimy, for lack of a better term. And so I'm going to keep stirring this. I'm going to get it nice and mixed. And so once everything is all said and done, we're going to have something that looks a little bit gross, in my opinion, but we have that right here for you guys. So this right here, it's still a little wet, so if we want to make it a little bit less wet, we can add a little bit more borax. And this is actually how we're going to be making the world famous MOSI Bouncy ball. It's adjusting the amounts of borax and water in the glue. Awesome. So now that that's done, aha, here we go. We have your first slime that you got going on today. Now this guy is pretty, well, slimy. And so this is technically a non-Newtonian fluid because it still flows like water, but like a solid, we can pick it all up at the same time. Pretty cool, huh? And this is messy, so if you're doing this at home, make sure you're rolling up your sleeves, maybe putting some cardboard or something down on the table or floor before you do this. I don't know if you wanna. Pretty fun stuff, huh?
Can you color it?
Yes, you can color it. I'll actually do that for my next one, because we do have a couple of colors here. So this is just regular borax and glue and water. Now, you could see how slimy that was, and I'm sure you guys could all see back at home how gross my table is right now. So I'm just going to wipe that up real quick so we're not mixing too much into one thing. Wonderful. So we have made official MOSI slime. The next thing that we are going to be making is the world famous MOSI Bouncy Ball. And this is actually, in my opinion, easier to make than full-on slime. So again, you take a whole bunch of glue, and I'll just make it right in here for you guys. And the interesting thing about this is that we're changing the ratio of borax to water. So, and I'll talk about what happens chemically after we finish this one. And so for this one, I'm going to take the same amount of borax. I'm going to take a half tablespoon, or half teaspoon, sorry, or 2 half teaspoons, 1 full teaspoon. And then I'm going to take about 1/8 of a cup of water after I clean this out. Whoa. That's the fun thing about slime, friends. It gets nice and messy. So we're going to take about 1/8 cup of water, and then we're going to mix this all nice together. Now, as you guys can see, it's very murky. And that's because the solution that we've created has a lot more borax than the last one does. And so this right here essentially means that there's more things for this to stick to. So I'm going to take a little bit of that borax water, and I'll bring this up to you guys in just a second. So I took about 3 half teaspoons about that. And so even before I start to mix it, you can begin to see, you can kind of see how it's starting to coagulate, starting to stick together. And so what I'm going to do is I'm going to keep mixing it, and keep mixing it, and keep mixing it. And so what's happening is everything is starting to kind of stick together. And so inside the glue, there's these long chains of polymers. And what essentially happens is that borax is taking those long chains of polymers and sticking them together.
How much borax in water again?
So for this one, I did about 1.5 teaspoons of borax to about 1/8 a cup of water. And so depending on how much you're making, you can adjust that. So, and we have this. Awesome. So once we've done, I've added a little bit more. We can see that it has turned into kind of this gluey ball, right? And so it's starting to stick together, but it's still a little too sticky for me to use. So after I put the borax in, I'm going to again take my borax cup and I'm going to give it a nice little water wash. And so what this is doing is this is reacting to all the glue on the outside. So when I finally get a chance to get my hands on this, it won't be as sticky. So, see how much less gluey that is? Wonderful. So I'm going to pull apart, and we're going to start working it in our hands. So what this is doing is it's adding heat to it. Because as you're doing this slime, or when you guys do this at home, you'll start to feel that it's kind of cold. And that's because it's endothermic, and that means it absorbs heat as it is happening, right? And so I'm just going to keep working this. And obviously we're going for a bouncy ball, so I want to start working it into a ball. Mine's still a little sticky, so if that happens, add a little bit more borax water to it. That's totally fine. As in all things with science, if you're trying something out, always feel free to adjust. I'm sorry. And so what's happening is I'm essentially taking some heat and applying it to this bouncy ball, and I'm taking some of the liquid out of it, right? And so once everything is all said and done, we're going to have something that looks a little bit like so. Now, if I did this correctly, which it feels still a little bit wet, it takes a little while, but I want to make sure that we're moving along for you guys. I should be able to bounce it. Here, I'll do it right here for you. Can you see that? All right, ready? 3, 2. Voila! We have officially made a bouncy ball. Now, if you're making this at home, be wary if it falls on the ground. It could pick up, whatever's on your floor, because it is still made of glue. It is still a little bit sticky, right? But as you work it, it's going to become harder, and it's going to become a little bit more elastic, right? And so essentially what's happening here today, see, so now that I've been working it, it's a lot easier to toss back and forth in my hands, and it's going to be a lot easier to bounce. So essentially, if I can find this guy, essentially what's happening is inside glue, there's all these long polymer chains. And so polymers are what we use to make up plastic. And it's essentially these long chains of similar material. And in glue, one of the reasons why it pours so slowly is because it has these long polymer chains. And they're all kind of sitting in there, doing what polymer chains do until you pour them out, right? And so when we make slime, essentially what we need to do is we need to take these long polymer chains and we need to stick them together, right? And so with the first slime that we made, this guy right here, we used, oh, and now that it's been sitting for a little bit, it's a little bit more slimy, gooey. It's more Newtonian, right? And so with this, the first thing that we did is we used more water than we used borax. So inside the borax, there's the boric acid that actually interacts and binds the polymers together. And so when we did the first slime, we took a little bit of borax and we attached a whole bunch of these guys together, right? And that made us a slime. Now, when we wanted the bouncy ball, we wanted this, but not as goopy and not as droopy, right? You guys can see that it's already being affected by the pull of gravity, right? So again, this is now that it's finally starting to set, the non-Newtonian fluid, it still kind of oozes like a water, but I can break it like a solid, right? That's what sets it apart from just any old liquid or solid, right? So I'm going to wipe my hands one more time, and I'm using way too many paper towels today. So this was our slime. We diluted the borax so there's less bonds, but when we have the higher concentration of borax, essentially what we did is we took all these polymer chains and we connected them even more. And so what that does is it starts to stick everything together. Okay, I hope that's enough illustration for you guys. I think you guys are getting the point. And so the bouncy ball itself has more of these bonds together, which allows it to stick together and maintain its shape better. Now, it is still glue, and this is not a perfect world, so if you do make this at home, it will start to be affected by gravity. It kind of looks like a little pile of ooze, but if you work it back in your hands again, it should be right back up to tip-top shape. Wonderful. Now, I know we have been here for a few minutes, but I did forget to make the slime with the color last time, so I'm definitely going to do it this time for our second slime that is also going to be posted on our website. Now, if you don't have any borax at home and you do have contact solution, you can use that. And we'll walk you guys through because the consistency is a little bit different than the slime that we had. So again, we're going to use 1/4 cup of glue. Oh, where's my glue cup? Ah, here it is. So we're going to use 1/4 cup of glue. We're going to add some food coloring this time, so I don't forget. And I'm going to do blue because it was the first color I picked and because blue's awesome. Alrighty, and just for fun, I'm going to stir this up a little bit for you guys, just so we can start to see some of that color happening. Now, I don't know if you guys can see it. It looks a little dark, but that nice rich royal blue is starting to come out. It looks pretty cool. I like the marbling that's got going on here today. Very nice, very nice. So we have our blue, right? Now, normally at this time we'd add water and borax, but what we're going to be doing is we're going to actually be adding saline solution, like contact solution, as well as baking soda. And I unfortunately could only find this big bag here, since we here at MOSI do this in bulk sometimes. So what I'm going to do is I'm going to do 1/4 tablespoon of baking soda. So, and now we're going to do one of these. So we have the baking soda, and we're going to mix it into this clean cup right here. I hope you guys are at home are enjoying how messy this is getting because I'm going to have to clean this all up. Alrighty. Alright, so we have our baking soda. Wonderful. And then we have our glue that we're going to be adding. And so we're going to slowly pour that in there. Very nice. Alrighty. So now, after we have done our glue and our borax, our glue and our baking soda, we're going to mix that up a little bit. Nothing's really happening because the boric acid is actually going to come from the contact solution. And so we're going to take about a half of a tablespoon. We've been using teaspoons so far, but half of a tablespoon. And we're going to add that in there. Nice. And so again, just like every slime, we're just going to start to mix it. And I don't know if you guys can see, but it's already starting to stick together. And just like with other slimes, the more you mix it, the better it's going to be. The more you play with it, the better it's going to be because the heat from our hands are going to add a nice element to help the boric acid stick to the polymer chains. So these are just two ways that you can make slime. You can put pretty much anything in slime that you want. If you have any glitter at home and your parent and or guardian says it's okay, by all means, go for that. Right? And then this is still going to start to slowly droop down. But if you don't have any of the stuff that we have here today, you can also make slime with laundry detergent. Just any over-the-counter laundry detergent. If you have this stuff, I'd recommend doing that first because the laundry detergent's really hard to wash off your hands. If you've ever accidentally dropped laundry detergent on the floor when you're trying to do laundry and it takes you like 17 paper towels to wipe it up, we've all been there. But it's hard to clean up and it's hard to get off your hands after you do the slime as well. So just be wary of that after you do that. I want to thank you guys all for tuning into my wonderful slime-filled MOSI session today. We'll be doing this, not slime, but we'll be doing different chemistry stuff all this week. So be sure to tune in every day at 1:30 p.m. Eastern Standard Time. I want to thank you guys for being an awesome audience today and keep discovering.